5.3 Solving Trigonometric Equations. What you should learn. Use standard algebraic techniques to solve trigonometric equations. Solve trigonometric equations of a quadratic type. Solving trigonometric equations involving multiple angles. And using inverse trig functions to solve trigonometric equations. To solve a trig equation, you're going to use standard algebra techniques such as collecting like terms and factoring. Our primary goal is going to be to isolate the trig function. We just want to get the trig function by itself and then we're going to solve it. Let's do this first one here. And usually I give you a domain. We'll start with degrees. So 0 to 360 is what we'll start with. We'll do degree one first. Degrees. We want to get this sine by itself. Just like a normal algebra problem, we're just going to try to get the sine by it. Add 1 to both sides. I get 2 sine of x equals 1. Then we're going to divide by 2. We're going to get sine of x equals 1/2. And then from here, how do we solve it? We basically do how we've been solving our trig functions, but in reverse. We're going to first make a table, make a chart with all students take calculus. I'm like, boom, boom, all students take calculus. And we're going to make triangles in correct quadrants. Here, sine is positive. Where sine is positive A, everything's positive A, and we're doing sine, so it's positive S. And it's negative here and here. This is our sine chart. And we're going to do lots of charts today, so don't worry about it. All students take calculus. Notice we're doing a positive sine of 1/2. I'm going to make my triangle in A and S because we're positive. Next, we're going to fill out the sides using SOHCAHTOA. We're going to fill out the sides using SOHCAHTOA. All that means is that we're going to go sine is opposite for hypotenuse. Angle is always the inside one. That's always your angle. Opposite to 1, hypotenuse is 2. Same thing here. That's my angle. Opposite to 1, hypotenuse is 2. And then we're going to use that. We're going to use 36 and 90 triangles, our knowledge of them, and 45, 90 triangles to figure out sides, to find angle goals based on sides. You have to know your 30, 60, 45, 40, because all we're doing is going reverse. What happens when this is 1 and 2? The angle is 30, because this has to be rad 3. The same thing there, 30. And the last step is find angles from origin. What angle is this guy right here? Well, this first one's easy. This is 0. That's the origin. And we're going up 30. So this is a 30-degree angle. That's the first one. But I also have to find this one. That angle is right here. Well, this is 30. This is 180 right there. How far is it from here all the way to there? From here to there. How far is that? We gotta get to the hypotenuse. 180 minus 30. 180 minus 30 is 150. And that's my angle. Those are my answers. 30 and 150. That is where sine equals 1/2 in from 0 to 300. That's a process. We're going to start with all students take calculus. We'll make triangles in our correct quadrants. We're going to fill out the sides using SOHCAHTOA. Then that's going to help us figure out what angle it is. And then we just got to find the angle from the starting point. There we go. Okay, let's do, now that we know the process, we're going to do more of them. And we're also going to do it in radians now. So this one, the equation is a little more difficult. What I want to do is collect the like terms. I want to put all the signs together. I'm going to move this sign over there because I don't like negative signs. I'll move sine of x. We're going to add it to both sides. We get 2 sine of x plus square root of 2 equals 0. And then next, we want to get the sine by itself. Let's subtract square root of 2 from both sides. I get 2 sine of x equals negative square root of 2. Then we're going to divide by 2. Sine of x equals negative square root of 2 over 2. Like that. Now, eventually you get so good that you can just do this in your head. Tell me what the answer is. But for now, we're just going to follow the process. Eventually you'll be able to do the process in your head. But for now, let's do it. All students take calculus. Sine is positive at A and at S, and negative at T and C. We actually have a negative one this time. We're going to do T and C, quadrant 3 and quadrant 4. Like that. We're going to do radians. This is 0 and this is pi. We'll do the rest if we need them. I guess 2 pi. Probably need that. Rad 2 over 2. SOHCAHTOA again. Opposite over hypotenuse. Rad 2 over 2. Now the one thing here is that's not a triangle we know. We don't know a rad 2 triangle. But we know the trick. Anytime it's radical 2, it's going to be 45. They just rationalized it. They got 1 over rad 2, and they multiply both sides by rad 2 over 2. They got rad 2 over 2. Anytime you see this, automatically it's 45. That's my angle here, 45. 45. Now, if I was doing this in degrees, my answer would be 180 plus 45, 225. Over here, this would be 360 minus 45, 315. But we want to do this in radians. The key thing about doing it in radians, we just got to remember that 45 degrees is pi over 4. We're talking about pi over 4s here. I'm going to do my same trick. This is 4 over 4. If we're going this way, we went one further. That says 5 pi over 4. One of our answers. If we went around again, 4 plus another 4, this would be 8 pi over 4. 8 over 4 is also 2. 2 pi makes sense. But we haven't got there yet. We're a little short. We're one less. We're at 7 pi over 4. And those are our answers. 5 pi over 4 and 7 pi over 4. That's a 7. That's a process. So we did one with 2 degrees, one did one with radians. Let's do a couple more. Now this one has a square. That's one thing. But also, if you notice, it doesn't say degrees or radians. So what happens here is they want a general solution. And it sounds like it's scary, but really all it is, once you get your answer, you're going to add 2 pi n. And that just means we're going to do every coterminal angle that involves. 2 pi is a coterminal angle. N just says all of them. The implication there is n equals 0, n equals 1, n equals 2. So that's what that implication is. Anytime it's a general solution, you're just going to get your answer and you're going to add 2 pi n to it. Let's start this one. We're going to add 1 to both sides. 3 tan squared x equals 1. Let's divide by 3. Tan squared x equals 1/3. We're going to square root it. Tan of x, remember anytime you square root, it's plus and minus. Now the square root of 1 is 1, so that tends to be a 1 on top. And the square root of 3 is square root of 3. So we have that. When we draw our little table here, it's plus and minus. We're going to do every single quadrant. You get a triangle, you get a triangle, you get a triangle, and you get a triangle. Try to make nicer triangles than I do. Tan is TOA, opposite over adjacent. I'm just going to focus on one of them here. Opposites 1 and rad 3. This is a 1, 3, 2 triangle. That angle there is 30. What's opposite 1? It's 30. So this is a 30-degree angle there. And they're all going to be 30. Now 30, if they don't tell you degrees, the default generally should be radians. 30 is pi over 6. This is going to be pi over 6, so you're in quadrant 1. We'll put pi here, 6 over 6. 1 less would be 5 pi over 6. 1 more would be 7 pi over 6. Then you go around to this side, and you get 12 pi over 6, also known as 2 pi. 6 and another 6 is 12. And you're 1 less than your 11 pi over 6. Our answer is going to be pi over 6. But again, we're doing a general solution. We don't want 0 to pi. We want all answers. So we're just going to add 2 pi n. So that means we get this answer here. Then we go another 2 pi. We go another 2 pi. You can also go backwards with the 2 pi. That's what that means. We're going to get all the answers. There's no interval. So we're going to get all the answers there. Now, if you're pro and you want to catch this one too, instead of saying 2 pi, you could say pi. Because that would go all around and get here. You could go 6 pi plus pi to save yourself some work. If not, just get every single one. And go plus 2 pi n. That's going to do all of them for this one. And then we could go 7 pi over 6 plus 2 pi n. And we could go 11 pi over 6 plus 2 pi n. If it's a general solution, they do want to see the 2 pi plus 2 pi n. If you're a little pro, you could save yourself a little work and go pi over 6 plus pi n, because that'll get this line right here. And then you can also do 5 pi over 6 plus pi n alternate, and you get that line right there. If you want to save yourself a little bit of work, if you notice, wait, it's just add a whole half circle there, then you can just put pi n instead of 2 pi n. But that's how you do general solution. You just do the same answer and add 2 pi n to it, because that gets all the coterminal angles. Next one, another one, general solution. They want us to factor this one. Notice, I gotta get everything to one side first. I could factor this. Let's minus 2 cotan both sides. So you get cotan x, cosine squared x, minus 2 cotan x. Equals 0. If you see things like I don't have a number, set equal to 0, and then see what you can do. And here I could factor these cotans out. Cotan x, cosine squared x minus 2 equals 0. We're going to split and solve each one separately. Cotan x equals 0. Cosine squared x minus 2 equals 0. Add 2 to both sides. Square root it. I get cosine of x equals square root of 2. Now you might wonder, wait, I don't remember having a cosine 2 over 1 for cosine. That's right, because cosine can't do it. Remember, sine and cosine have to be between 1 and negative 1. Always think about the graph. Here's my graph of cosine. The basic cosine graph goes between 1 and negative 1. Anything that's bigger than that or smaller than that, it cannot fit. This is too big. No solution. No solution to that one. Where does cotan equal 0? Probably best to go, what is cotan? Cotan is sitting as cosine x over sine x equals 0 over 1. So really all we're trying to figure out is where does cosine equal 0? Because that's what the top equals. If you're not sure, you could cross multiply and you'll get 0 equals cosine x. That's really all we're solving. Where does cosine equal 0? So that's a unit circle problem, right? Here, here, here. When sine and cosine are 1 or 0, it's going to be on the unit circle. So this is 1, 0. This is 0, 1. This is negative 1, 0. This is 0, negative 1. 0 pi over 2, pi, 3 pi over 2, 2 pi. Cosine is the x value. Sine e, cosine x. We're looking for the x values. Which one of these has an x value of 0? And it's 2 of these. It's pi over 2 and 3 pi over 2. And keep in mind, they did not give us a domain, so we had to do the general solution. So I'm going to do pi over 2 plus 2 pi n and 3 pi over 2 plus 2 pi n. But if you notice, if you want to, you can make this shorter and just go, wait, they're on the same line. I could just add pi. If you want, you can also just do pi over 2 plus pi n. That's the shorter version of doing this. That way you get all of them. If not, you can do this. That's also correct. A little more work, but it's correct. But the shortcut is I just could do this one and add pi and keep on going around in circles. So either way is fine. But again, anytime they don't have a domain, they generally want the general solution. So you just get your answer and you add 2 pi n. Okay, how about equations in the quadratic type? Looks like ax squared plus bx plus c. It's quadratic type. And anytime it looks like that, you could factor it just like a normal quadratic. Now, sometimes it's hard to see it. It's hard to factor that. Like you just can't see it. I do a little trick. My trick here, like if I want to factor this, is I let the sine x equal w. It's called use substitution. I just like using w instead. This becomes 2w squared minus w minus 1 equals 0. And for me, that's a lot easier to factor than trying to factor it with the signs. So you could do a big X or whatever you want to do. 2w, it is 2 and negative 1. Oops, negative 2 and positive 1. This reduces to w over negative 1. We get w minus 1, 2w plus 1 equals 0. Then you can either plug your sign back in or just solve it. W minus 1 equals 0 and wait till the end to plug your sign back in. W equals 1. Subtract 1 divided by 2. So you're going to get w equals negative 1/2. And then here you do have to go back and plug your sign in for your w. And then sine of x equals negative 1/2. And once you get down here, you still got to solve it. You're not done yet. You still got to solve the problem. So solve sine of negative 1/2. We're going to go a little faster now. We've been doing this a lot. All students take calculus. Sine is positive at a and s, but negative at t and c. That's where I'm going to draw my triangle. Sine is so over h. Opposite negative 1, hypotenuse 2. And from that, we should know what type of triangle it is. It's 30, 60, 90, 1 right 3, 2. This is 30. 30 gets the 1. 30 is always opposite of 1. If we're doing this in radians, 30 is pi over 6. That's right, 30 is pi over 6. So this is pi, which is 6 over 6. We go a little past that, we're going to get 7 pi over 6. Go around again, 12 pi over 6. A little short of that, haven't reached it yet, is 11 pi over 6. And it is on the intervals, we're good. We don't have to add 2 pi n. I still have to solve sine equals x. That's its own chart. Anytime sine or cosine is 1 or 0, it's the unit circle. It's the quadrantal angles. We got 1, 0, 0, 1, negative 1, 0, 0, negative 1. This is 0. This is pi over 2. This is pi. This is 3 pi over 2. Sine is the y value. Where does the y value go in at? Right there. Our answers are 7 pi over 6, 11 pi over 6, and pi over 2. Okay. So this one, if you look at it, we have 2 sine squared plus 3 cosine x minus 3 equals 0. They don't match. What happens here is you want to write them all with the same trig function. Now, cosine by itself, you can't do anything. But sine squared, we could change that one. Sine squared equals 1 minus cosine squared. We're going to change that to 1 minus cosine squared. That way, they're all the same trig function. Everything else stays the same. Also, if you look at it, there is no domain. We're going to do a general solution. We're going to add 2 pi n to everything. Anyway, let's distribute. You get 2 minus 2 cosine squared x plus 3 cosine x minus 3 equals 0. Add like terms. Negative 2 cosine squared x plus 3 cosine x minus 1 equals 0. I don't like factoring with the negative in front with my square is negative. I'm either going to move everything to the other side or divide by negative. Anyway, you want, but I prefer to not have to factor with leading coefficient negatives. In my head, I usually just move everything over. I just add everything to the other side. We have this. Again, you have to factor it. If you're not good at factoring it the way it is, just make w equal cosine x. I get 2w squared minus 3w plus 1 equals 0. We're going to factor, let's see, 2, negative 3, negative 2, and negative 1. 2w. That's w over negative 1. W minus 1, 2w minus 1. Equal to 0. We're going to split and solve. We're going to get w equals 1 and w equals 1/2. I just added 1 divided by 2. Don't forget to put back your cosine. Cosine x equals 1. Cosine x equals 1/2. Both of these we could solve. Cosine is positive. All students take calculus at A and at C. SOHCAHTOA. Jason's 1, hypotenuse 2. The thing I like about cosine, that doesn't help me. I got to figure out the missing side, which in this case is radical 3. It's 60 degrees. 60 is pi over 3. So this is pi over 3 because in quadrant 1. This would be 3 over 3. Go around again, you get 6 pi over 3. So this would have to be 5 pi over 3. So there's no shortcut. If I was doing my answer, it would be pi over 3 plus 2 pi n because they want the general solution. And it would also be 5 pi over 3 plus 2 pi n. Because there's like no way to get a shortcut of that. What does cosine equal 1? It's kind of give us the answer. It's right here at 0. It's 1, 0. Cosine's the x value at 1. I'm going to put 0 plus 2 pi n. And that's the general solution for all of these. And that's the lesson.